in order to understand how the steering gear works, we're going to need to briefly discuss the topic of hydraulics and take a look at some of the steering gear's main components. Now in the past, when you wanted to steer a ship, you could do it mechanically. You would find a muscly sailor, you would stand him next to a big wheel, which is referred to as the helm, and he would turn the helm to port or to starboard in order to change the direction of the vessel. The helm was connected via pulleys and levers to the rudder, and that's what actually caused the vessel to change direction. Fast forward several hundred years, and ships are now so large that it's not possible for a single person, or in fact many people, to manually adjust the position of the rudder using pulleys or levers, etc. So how do we adjust the position of a rudder, accounting for the fact that the rudder may weigh several tons? Well, in engineering, there are four main ways used in order to actuate something. When we're talking about actuation, we're referring to movement. If we want to actuate a valve, move it from the open to closed position, or any position in between, then we might do this mechanically, perhaps by using a hand lever or a hand wheel. We may do it pneumatically, using compressed air. We may do it hydraulically, often using some sort of oil, or electrically, using some sort of electromagnet or electric motor. Modern steering gears are predominantly electro-hydraulic. They use an electric motor attached to a positive displacement pump, which pumps hydraulic fluid within a hydraulic system. So let's take a look at that in action. Here we have our steering gear. Beneath the steering gear we have a rudder, and further forward or further to the fore we have a propeller. If I press the play button, we can see the propeller turning. If I zoom out a bit, we can actually see the rudder changing position. The rudder now is coming to port. The rudder now is coming to starboard. The rudder is attached to the steering gear via a rudder stock. You can actually see it here. The rudder stock runs up through the rudder, through the hull of the vessel, and connects to our steering gear, which is this green item here. Connecting to the rudder stock is a tiller. This type of tiller is a forked type tiller because it has a fork shape. Between the forked tiller is a pin and a codpiece. Don't ask me why it's called a codpiece, it just is. The pin connects onto a ram. You can see that there's a ram on the opposite side here, and it's these rams that are used to move the rudder. The rams move in a linear direction, either moving to port, which is towards the left side of the screen, or starboard, which is towards the right side of the screen. Although the rams move linearly, the rudder stock moves in a rotary direction, and it's the tiller that converts this linear motion from the rams to rotary motion at the rudder stock. You can also see the keyhole where the rudder stock attaches to the tiller. Over on this side, we can see a rudder angle indicator. The rudder angle indicator here goes from 0 to 45 degrees on both sides, but typically the rudder will only move between 35 to 35 degrees maximum. Once you get past 35 degrees, the rudder is no longer so effective, and it's definitely not as efficient because you get small eddy currents or eddies, which create turbulence and reduce the efficiency of the rudder and the turning effect it creates. It's a requirement that the steering gear should have some form of local rudder angle indicator. So fixing this plate onto the tiller is a pretty good way to fulfill this requirement. Attached to the top, you'll see we've actually got two bars, these two thin connections. These connect usually to a control box and some sort of position indicating transmitter. And we can transmit this signal back up to the bridge so that they can see the position that the rudder is currently in. So a local rudder angle indication is provided here, and a remote rudder angle indication is provided via a transmitter, which transmits a signal that is received in the wheelhouse, also known as the bridge. Aside from that, on both sides of the steering gear, we have an electric motor, one here and one on this side, and we have some directional control valves. Here is the one. And go round to this side. Here is another. Encasing the rams are cylinders. There are actually 4 cylinders on this type of steering gear. This is known as a 4-ram type steering gear. It's also possible to get 2-ram type steering gears. Those are the 2 ram type steering gear designs that you're likely to encounter, the 2-ram and 4-ram. And the other type of steering gear design that you may encounter is the rotary vane type steering gear, which we can cover in another video.